Hey, Chemsters, we're on chapter 7.3 notes, page 6. So we're going to be looking at mole mass and mole volume relationships. So here's our I can statement. I can interconvert between mass and moles. So we're going to use the molar mass of an element or compound to convert between the mass of a substance and the moles of a substance. So question 1 says, what is the mass? So circle mass, put a question mark, that's what we're searching for, of 9.45 moles of aluminum oxide. Underline that, that's what we're given. The molar mass, where do I find the molar mass? Raise your hand if you can tell me. Bailey, where can I find the molar mass? Periodic table. Perfect. So anytime I say molar mass, Elizabeth, you're going to say periodic table. Perfect. If I said periodic table, Miley, you would say perfect. Okay. Excellent. So actually right now I want you to take out your periodic table, figure out what is the molar mass of aluminum oxide. I will pause and I will wait. Write down your molar mass right here. Perfect. So using the periodic table, Sydney, can you tell me what you got? Perfect. 101.96 grams per mole. So as the molar mass, 1 mole of aluminum oxide has a mass of exactly 101.96 grams. So now we're going to set up our problem. So take what you're given, put it over 1. So we know that we have 9.45 moles, and put it over 1 just to make an improper fraction. And the next question we ask ourselves is, okay, how do I get rid of moles? So everybody, where must moles go in the next fraction? That was really sad. It goes in the denominator in the bottom, right? And then we're going to go to grams. So this is your setup. And before you do any math, check to make sure that your units cancel out. So if we have moles in the numerator and moles in the denominator, it will cancel and you will be left with grams. So that is good because that's what we're trying to find. Now we have to actually figure out the conversion factor. So what is bigger, everybody, a gram or a mole? A mole. So 1 mole is exactly how many grams? No, not 6.02. Interesting suggestions. Look at the math you just did. The molar mass of aluminum oxide is 101.96. So if we look at our math, 1 mole of aluminum oxide is 101.96. Thank you. Those are all common mistakes. So it's not 6.02, and it's, you gave me the conversion factor for grams to pounds, which that's something. Okay, so now I want you to please pause the video, type this into your calculator, write down your full answer, and then round for sig figs afterwards. Perfect. Thank you for pausing and trying the math on your own. Your calculator should have said 963.52 grams. This right here is your calculator answer, but look back to the original problem. Decimal is present, so count from the first non-zero on the Pacific. There are 1, 2, 3 sig figs. So on this number, here's my first, second, third sig fig. Look to the right, it rounds up. Final answer, circle it, is 964 grams of aluminum oxide. Good job, Chemsters. Super proud. Questions on the first problem? No? Let's look at number 2. So what is the mass of 0.76 moles of carbon disulfide? Well, I gave you the answer here, but figuring out the molar mass of carbon disulfide, take the molar mass of carbon, which is 12.01, plus 2 times the mass of sulfur. Who can tell me the mass of sulfur? Look it up. What is it? Go ahead, Adam. Perfect. So you're actually taking 32.07 plus 32.07 plus 12.01, and that's how you get the 76.15 grams. So let's look at the setup now. You are given 0.76 moles. Put it over 1 to make a fraction. And then we need to do the units before we can do any of the math or the numbers. So moles is on top. Everybody, moles then must go on the bottom or the denominator. Good. So moles goes down here. And we want to get to mass, which our unit is grams. And if you check moles and moles cancels, you'll be left with grams. So we got to figure out our conversion factor. 1 mole is bigger. And from the periodic table, 1 mole of carbon disulfide has a mass of 76.15 grams. So at this point, make sure your setup's correct, pause the video, and write your calculator answer, and then your correctly rounded sig fig answer. If you got 58, good job. Your calculator answer should be 57.874. Original problem has 2 sig figs. Decimal is present, but the first non-zero isn't until the 7, so 1, 2 sig figs. That would round up to 58 grams of carbon disulfide. Let's check out the next problem. Uh-oh, things just got real, right? How many moles, question mark, are there in 92.2 grams of iron 3 hydroxide? Oh no, I shouldn't have told you the molar mass yet. Pretend you can't see it. We're going to hide it. So you have no idea what the molar mass is yet. We have to figure out the molar mass. How do I find out the molar mass? I look at the periodic table, perfect, but what else do I need, Sydney? Good guess, but no. We need the formula. So we got to figure out what the formula is for this name. So if it's iron 3 hydroxide, the charge of iron is 3 plus. Hydroxide you have memorized, so it is OH1 minus. So then what is the final formula of iron 3 hydroxide? Go ahead, Bailey. Perfect. So this is the formula you're finding the molar mass for right here. Because we have iron 3 plus and hydroxide 1 minus, you got to do your crisscross and get the charges to cancel. So I want you right now to check that on the periodic table. And when you get an answer, go ahead and shout it out. 106.88. Great. Good job. So that is the number we'll use moving forward. You took 16, probably plus 1.01 times 3 plus the molar mass of iron, which is 56 something. So let's set up our problem. We have 92.2 grams of iron 3 hydroxide over 1. So we want to get rid of grams and go to moles. So my next part of my work here, put grams on the bottom, go to moles on top. A mole is bigger, so the mole gets the 1. And you just looked up from the periodic table, 1 mole of iron 3 hydroxide is exactly 106.88. So at this point, pause the video, do the math, and round for sig figs. Okay, so we're taking the numerators, divide by the denominators. So basically you're doing 92.2 divided by 106.88. Your calculator will tell you 0.8626 something. We only need 3 sig figs though, so 1, 2, 3 sig figs. Look to the right. It becomes 0.863 moles of iron 3 hydroxide. Circle your final answer. On the test for a question like this, I would expect you to show every single step exactly how I have it here with your units, your conversion factors, calculator answer, and correctly rounded sig fig answer. Let's try question 4. How many moles are there in 0.8084 grams of calcium phosphate? So what is the first problem I have to tackle? Calcium phosphate. I gotta figure out what that is. So calcium, alkali earth metal, column 2, it's a 2 plus. Phosphate you have memorized is PO4 3 minus. Do your crisscross. So what is your final formula for calcium phosphate? Go ahead, Bailey. Yep. So it would be Ca3, that 3 comes from the phosphate, parentheses, PO4 2. So then you're going to want to look up the molar masses for each element, multiply through to figure out how many times you need that, and you should get 310.189 or 0.18 grams. Don't take my word for it though. Pause the video, check your work, and see if you get 310.18 grams. Good job. Thank you for pausing. Oops, uh-oh. So what we're given is 0.084 grams, put it over 1. The next step, I need to get rid of grams, so it goes on the bottom. I'm trying to get to moles, moles is on top. And by definition, 1 mole is exactly 310.18 grams. So again, pause the video, take the numerators, divide by the denominator, and then write the calculator answer, and then round for sig figs. Okay. Good job, Chemsters. If you had 2.70810 times 10 to the negative 4th moles, you did it perfect. But then you want to round to only 2 sig figs. Those first zeros are placeholders. That becomes 2.7 times 10 to the negative 4th moles. You could go standard notation if you want, or keep it in scientific. That's also fine. So the new topic we have to look at is the mole-volume relationship. So make sure you underline, highlight, star this. This is really important. This is a given you need to know. At standard temperature and pressure, which we abbreviate STP, the volume of 1 mole of any gas is 22.4 liters. Any gas, could be a noble gas, could be hydrogen, could be xenon tetrafluoride, anything. STP means 0 degrees Celsius in 1 atmosphere. You will always assume that for this unit because what happens to gases when they get hotter? What do? They expand, they get lighter, like hot air balloons. So we're saying we're setting that everything with the gas is happening at 0 degrees Celsius, freezing temperature, 1 atmosphere pressure. So we have a new conversion factor. Now we can go from moles to liters. So for this first problem, how many liters, this is my question mark, are in 0.375 moles of oxygen gas at STP. So for the setup, 0.375 moles over 1. And then I need to get rid of moles and go to liters. So moles on the bottom, liters on the numerator. And then we need a new conversion factor. I'm telling you that 1 mole is exactly 22.4 liters. So that's your conversion factor. 1 mole is 22.4 liters. And when we check that math, you're going to get 8.4 liters from your calculator, which is a problem because you need 3 sig figs. So to make it more precise, we just slap a 0 at the end of the number. That tells me we are certain about that 100th place value. So you might have to add zeros to say I'm certain about that decimal place. And we got one more example on this page. How many liters, question mark, are in 32.8 moles of nitrogen dioxide at STP? So take what you know over 1, and then set up your units to cancel. Get rid of moles, and then we want to go to liters. There's our new conversion factor. So we know that 22.4 liters is 1 mole. And when you plug that into your calculator and check, you will get 734.72, but round that to 3 sig figs gives me 735 liters of gas. Any questions on page 6? No? Okay. Let's flip and go to page 7. More of the same, really. I'll go a little bit faster on this one because I think you're probably getting it. So now I'm going the other direction. I am given liters and I want to get to moles. So everything just flips on the conversion factor. So we've got 25 liters over 1. We need to get rid of liters so it goes on the bottom, and mole is on top. So if you look at the conversion factor, 22.4 liters is 1 mole. I'm taking 25, divide by 22.4. If you guesstimate that, it should be something a little higher than 1. Plug it into your calculator, you will get 1.11607 moles. Look back to your original problem. Right here, we got 2 sig figs. So 1, 2, round it, and it will stay 1.1 moles of NH3 ammonia. If you thought number 3 was easy, you'll love number 4. It's like the exact same thing. So again, we are given liters, 0.08 liters. Get rid of it, put it in the denominator. I want to go to moles. The conversion factor we told you, 1 mole is 22.4 liters. So I'm taking 0.08, divide by 22.4, plug that into your calculator, and you should get 0.00357142 moles. I only want 1 sig fig. These are all placeholders in front. Remember, present Pacific, count from the first non-zero from the left. So that is going to actually round to 0.004. You could leave that standard form, or you could go into improper scientific notation if you really wanted to. This one's not too bad to write all those zeros, though. So then I want to cover one more thing in the last 2 minutes we have of the video. Our other objective is I can interconvert between mass, moles, and number of particles. So we're going to use the mole like a bridge. Always go to the mole first. So if you don't know what to do, find out moles. If it's a one-step problem, if the mole will be part of the problem. We'll be given the word mole. If there is no mole mentioned, it will be a two-stepper. So I want you to visualize your land of mass and your land of atoms. The mole is the bridge. Put a note by molar mass, get it from the periodic table, and for the land of atoms, change your notes. We're going to use 6.022 times 10 to the 23rd always. So let's just look at the first problem, figuring out, is it a one-stepper or a two? How many grams are in 23.8 moles? Am I given moles? Yes, therefore it's a one-stepper. So I have 23.8 moles. Moles go into grams. So this one, though, we need to find out the molar mass of iron, which you get from the periodic table, which is 55.85. That's the average mass. So we're taking 23.8 times 55.85 divided by 1 times 1. So your final answer would be 1,329.23 grams of iron, but got around to 3 sig figs. That would give me 1,330 grams of iron. That was a simple one-stepper. I want to show you one two-stepper before we run out of time. We got 30 seconds. Oh, can we do it? This one, mole is not part of the problem. We want atoms. We're given grams. So it means we're going to go grams to moles to atoms. It is a two-stepper. Here is the setup. Given grams, get rid of grams, go to moles. You're at moles, get rid of moles, go to atoms. Here are your conversion factors. Here's your final answer, and I will do another video explaining more. Thank you, Chemsters. Don't wait to be great.